So hello everyone, John here. In this video I would like to share with you the law of cosines. Well, the law of cosines is very kind of a fun thing. Basically with the law of cosines you can calculate many important and fun things in mathematics. So let me first draw some sort of triangle here. Let's say you have a triangle like this, and now if you had a triangle like this and this was A, B, C, and this was basically then side A, side B, and side C, basically the law of cosines says that the law of cosines, it says that c squared, it means this side whole square, this side squared, is equal to a squared plus b squared minus 2ab cos c. Right, this is basically angle c. Also in the same triangle, a squared is equal to b squared plus c squared minus 2bc cos basically the angle that goes between these. Here I have cos c, right? So here I have cos a, b squared plus c squared cos a. So cos a, and also b squared is equal to this side whole squared is equal to a squared plus c squared minus 2 ac cos b is the angle between these two sides. So side A and side C, the angle between them is b, so cos b. So that's basically the law of cosines, and let's see how we can derive these relationships. Well, the way you can do that, in the same triangle you can draw a perpendicular from vertex B, from this vertex B. Let's say this is the perpendicular, and then this would be H. Now here you can calculate sine A. If you want to calculate in this triangle, sine A would be easy. So sine A is equal to basically H divided by C. So then H would be equal to C sine A. And if I call this R, this distance from here to here, so then cos A would be equal to R divided by C. So then R would be equal to C cos A. go a few steps back. C cos A. So C cos A. Yeah. So now you have, you know what H is, what the length of what's the measure of H and what's the measure of R. Now in the triangle CBD, if you call this point D, in this triangle CBD, you have, in triangle CBD, you have A squared is equal to H squared plus this distance whole squared. So you have A squared is equal to, this is the Pythagorean theorem. So A squared is equal to H squared plus this whole squared. So this distance would be basically, the whole thing is B. So this is basically B, right? And this is R. So this is R, this is B. So this distance would be B minus R. So B minus R whole squared. And but here we calculated what we calculated the values of R and H, so you can substitute them here in this formula, and then basically have everything in terms of C sine A and C cos A. So let me see what happens here if I do that. So if I do that, A squared is equal to H squared, so C sine A whole squared plus B minus R, so B minus C cos A whole squared. Now you can simplify this. You can write this as A squared is equal to C squared sine squared A plus, so this would be B squared minus 2BC cos A plus C squared cos squared A. Then here you can simplify things again. You can write these two, we can put them together. All of these two, you can put them together. This is C squared into cos sine squared A plus cos squared A, and so I can factor this out. So you can write A squared is equal to, you can factor out a C squared because you have C squared here, C squared here, and here you can write sine squared A plus, and this one C squared have you factored out, and then you can write cos squared A plus B squared minus 2BC cos A. But you know that this whole thing is already 1. This is basically 1. So then you can write this as A squared is equal to C squared plus B squared minus 2bc cos A. And that's basically this one that we had over here. So, and in the same way you can derive the other two as well. So that's a very useful formula. You can use it in many different instances. That's the law of, that's basically the law of cosines. That's it. So now we have the law of cosines. We have still a couple of things in trigonometry to cover before we can move on to calculus. I'll see you in the next video.